Before you continue on your journey in the world of Blueprint visual scripting, I thought it best that we discuss some of the caveats that you should know about and consider along the way. So we know that blueprints are super powerful. Why don't we just do everything in Blueprint then? It's entirely possible, but there are some things to consider. One of those is that there is a cost associated with using Blueprint over C++ code. I don't want you to get too concerned with this just yet, but do know that there are certain things that will impact your game or application's performance more than others if they are done in Blueprint. For example, doing a lot of complex math or heavy operations on every frame, you may want to move this to C++ code, as Blueprint runs in a virtual machine to translate your Blueprint nodes into native C++ code, and that's where the cost is incurred. There's also no easy way to say this. C++ code is going to be faster than Blueprint. You do not need the virtual machine to translate your code. It's also going to be a little bit more powerful, as there are some elements of C++ code that are not currently exposed to Blueprint, meaning that there are some things that can only be done in C++. Having said that, there are many games and applications out there that have been created entirely in Blueprint. Another thing to know, Blueprint is event-based, meaning some type of event starts the chain of other events or functionality to occur. That event could be the start of a game or application, when the player runs into a wall or picks up an item, for example. These are all events that could start or kick off your Blueprint script. And finally, I've saved this one for last, as this is the one that you will probably encounter the most when first starting to work with Blueprint, is that Blueprint uses references to access data and functionality between multiple blueprints. So if you're not careful, you could run into situations where you return an invalid reference, which would produce errors. There's also the possibility of running into circular dependency issues, which I'll come back to in a moment. But first, let's take a look at how references work. So here we are inside of the editor, and we're going to take a look at a couple of examples with regards to references inside of UE4. So let's look at 6.1 here. So we have a button here, and we have a couple lights up here. When we go over the button, we want to turn on one of these lights. So if we play in the editor, and we approach the button, and we go over it, nothing happens. None of the lights come on. In fact, if we escape, we're getting a nasty little warning down here at the bottom, which we can click on. If we click the show message log, it'll give us a little bit more information. And we're getting an error inside of our blueprint, so our blueprint is not set up correctly. If we use the message log to our advantage, we can diagnose what's going on with our blueprint and where the problem may be. So the error that we received is that we are accessing none trying to read property reference to light. What's really cool about the message log here is that you can actually navigate to the source of the problem directly from the message log. So each of these links, we can click on them and jump directly to the problem. So at the very end here, it looks like we have a function called turn on light. If I click on this, it's actually going to open up the blueprint and take us right to that node. And the problem that we are seeing is that we are attempting to access a variable, but we're accessing a null variable. There's nothing there. We're not accessing anything. And we are trying to read property reference to light. So if we look at our graph here, looks like this is the function that's being called, and we are trying to read reference to light. So that's what it's targeting, but it's not getting any data that it can use. So let's take a look at this. I'm going to close this out, and we're going to look at the blueprint in the level here. So here's our button, and when we go over the trigger volume, we want to turn on one of these lights. If you look in the details panel, we have a property called reference to light. And you can see it's currently set to none. So this is probably where the error is. We need a reference to which light we want to turn on. Even if we had one light and we want to turn on just one light, we still need a reference to the light that we want to turn on. So this is our problem. Now we could click the drop down and select from the list all the available lights. You can also use the eyedropper here to kind of pick one of the lights from the scene. So I'm going to go ahead and pick this one here. Now that we've assigned that reference, we know that when we enter the trigger volume, we want to turn on this particular light. So I play now and I walk over to the button, I turn it on, the light comes on, and it fixes the error that we had. Conversely, we could choose the other light if we wanted to as well, just like so, and it would turn on the other light. So that is references for this first stand. We're going to look at 6.2 here and talk about casting, because this is something else that you might run into when working with blueprints. Now suppose we had something else in our scene that was a physics object. And suppose we move this over on top of the button, something like this. And if we played, the ball turns on the light. The physics object actually hits the button and turns on the light. Now, suppose we don't want that. Suppose we only want the player to actually go over the button to turn on the light. This is where we could use what we call casting. So I'm going to move that back over here for a second. And I set this blueprint up just a little bit differently. If we open this up and we right click on it and open the blueprint, what we're going to have in here is a little bit different script than the other one. As soon as we overlap the collision volume, we're now running a check to see what is it that overlapped the button. And we're doing that by taking the other actor, the other thing that overlapped the collision volume, and using what we call a cast. We're casting to see, is it the player that overlapped it? So another way to explain casting is you're checking to see if one object is another type of another object. So we're saying, is the other actor the player? If it is, then go ahead and turn on the light. If it's not, then we're going to print to the screen that we've failed. So let's actually test this out. Let's make sure that we have assigned a reference to a light. So we'll turn on the left light here, like so. And if we take this ball over and drop it on top, we should get a failed. It doesn't turn on the light, which is what we would expect. However, if we move the ball out of the way and we play and we go over the light, or the button should turn on the light, as we'd expect, because it casted to and checked, is it the player that overlapped the button? What we could do if we wanted the ball only to overlap the button and turn on the light, what we could do is we could right click, edit, and instead of casting to the player, we could check, if we look in the outliner here and we select the ball, we can see that this is a static mesh actor. That's what this object is that we have selected. What we could do is say, is the other actor cast to static mesh actor, like so. And if we connect that up, connect this up, now we're saying, is it a static mesh actor that overlapped? You just drag that off screen for a second. And if we move this on top, like so, now the ball can turn on the light. So that's what casting is. You're kind of throwing out a net, trying to see, is the other object that you are casting to of a particular type? And that's what we've done here to see if we want the player or another object to turn on this button. Another issue that you might run into is what we call circular dependencies. And these occur when you have two or more blueprints that depend upon one another. For example, we have two blueprints here on this slide deck here. They're not the fanciest blueprints, but we have blueprint A and blueprint B. So say, for example, blueprint A casts to blueprint B to access a variable stored inside of it. Blueprint B then casts back to blueprint A to maybe call a function or access a variable inside of it. When you load blueprint A, it begins to load all of the dependencies that it has. Since it depends on blueprint B, it also begins to load. As blueprint B loads, it then depends on blueprint A. So again, it loads blueprint A. So this vicious cycle continues. And because both blueprints depend on each other, this may significantly increase load times, or it may fail to load entirely, resulting in errors. Again, these things are things to consider, things to keep in mind when working with Blueprint, and Blueprint does a pretty good job of warning you when invalid references or circular dependencies are detected. Don't be alarmed, however, if you run into any of the caveats we've mentioned. Practice makes perfect with Blueprint. The more you use it, the more you'll be accustomed to the nuances of the system and feel more comfortable in your scripting ability. That will do it for this video. You should now have a high-level understanding of some of the things to watch out for when working with Blueprint. As with anything, do expect a little trial and error to start, and that's perfectly fine. You do have enough knowledge, however, to jump into the editor and start your hands-on work with Blueprint visual scripting. So have at it, explore, and return to this series if you ever need a refresher.